Alright, so section 11.1 we're going to be talking about ratios and proportions, so make sure at the end of the lesson you can find and simplify the ratio of two numbers and solve proportions, and then also use proportions to solve some real life problems. So what's a ratio? There's actually three different ways that we're going to look at ratios in this chapter. Probably the most popular one is as a fraction. So if we're looking at the ratio of two numbers a and b, we would just write it as a to b, or we can do it with a colon. So we could write it a to b. Notice I said it the same way, a to b, and we can actually use the word to. So with the word to, and we would simply write it as a to b. And again, this one here, that's going to be most often used. Alright, we're going to use that one almost all the time. So let's move on to the examples here. Example 1, we want to write the ratio comparing 17 big steps for every 2 minutes, 3 different ways. So let's start with a fraction. So we're going to have 17 big steps to 2 minutes. So that would be as a fraction, or 17 big steps to 2 minutes with a colon, or with the word to, 17 big steps to 2 minutes. Alright, moving on to B. Again, just pause, rewind as needed. We want to simplify the ratio of 18 big steps for every 3 minutes to its lowest terms. So let's write this as a fraction. We've got 18 big steps to every 3 minutes, and then each of these numbers is divisible by 3, so what I'm going to do is I'm going to do 18 divided by 3 and 3 divided by 3. So 18 divided by 3 is 6, so that would give us 6 big steps, and 3 divided by 3 would give us 1 minute. So this ratio, 18 to 3, it simplifies to 6 to 1. 6 big steps to 1 minute. Alright, moving on. Example C, it says the dimensions of a nearby dog park are 21 feet by 40 feet. What would be the dimensions if the Chicago Park District doubled the size? So now we're going to double the width and we're going to double the length. So 21 times 2 would be 42 feet, and 40 feet times 2 would be 80 feet. So this might be a good time to pause and see if you can fill out the next two parts of this example C. So if you did pause and now you're resuming, double check that, make sure you got 63 feet by 120 feet. Again, since we're tripling the sides, we're going to take 21 times 3 and 40 times 3. And then if we quadruple the sides, you should get 84 feet by 160 feet. Alright, so let's take a look and rewrite the new park dimensions as a ratio and simplify. So dimensions of the park doubled. That would be 42 to 80. And then if we simplify that, we get 21 to 40. And then if we tripled it, the dimensions were 63 by 120, 63 by 120. So again, if we reduce that, that's going to be 21 to 40. And the last one was 84 to 160. And if we reduce that, you guessed it, it's going to be 21 to 40. So think about what did you notice about all of the ratios? Why does this happen? Go ahead and fill that in, and then when we get to class, we'll see what everybody wrote down and compare our answers for that. Alright, moving on to page 2. We're going to look at the information that we had from the previous example and kind of fill in this chart. So again, if you want to pause it and fill this out, see if you did it right. The width, if we tripled, would be 3 times 21, which was 63. We already figured that out. And the length would be 3 times 40, so that would be 120. So now if we're looking at the total perimeter, we know we're going to have two sides that are 63 and two sides that are 120. So a little shortcut for finding the perimeter, we're going to have 2 times 63 plus 120. So that's going to give us 366 feet. And since it's perimeter, that's linear units, so we really don't need these squares over here. So let's get rid of those. Then if we could quadruple, we're going to take each of the dimensions and multiply by 4. Let's make that a 21. So that's going to give us 84, and then 4 times 40, that's going to give us 160. So again, using our shortcut for perimeter, we're going to have 2 times 84 plus 160. That's going to give us 488 feet. So now what if we're going to multiply it x times? So we want to introduce a variable in here, so we have a formula that we might be able to use for anything. So for this, really, whatever we're multiplying it by, 2, 3, or 4, now we're going to multiply it by x. So this would be 21x. We're just going to put the variable in the back instead of the number that we had in the front. And this would be 40x. So now if we're looking for the perimeter, it would be 2 times 21x plus 40x. Okay, and then we could do some simplifying here if we wanted to. If you want to go ahead and simplify, it would be 2 times 61x, or 122x feet. So see if you can notice anything about this answer that we came up with over here. Alright, so what patterns do you notice in the above table? Again, pause the video, go ahead and fill that out. When you get back to class, we'll compare our answers and see what we got there. Alright, moving on to example 2. So now we know the perimeter of a room is 108 feet, and the ratio of its length to width is 7 to 5, and we want to determine the length of the room. So let's draw a little sketch of our room, and I always like to mark what I know, so I know that the perimeter equals 108 feet. And since the ratio of the length to width is 7 to 5, if we use our table at the top of the page, we can kind of show that this would be some 7 times x, and this would be some 5 times x. So whatever x turns out to be, when we reduce it, it will always reduce back to 7 to 5. Alright, so if this is 7x, I know this is 7x. If this is 5x, I know this is 5x, because we have a rectangular room. So I know if I add up all of these sides, so again I'm going to use my little shortcut, but you can write it out however you like to, it would be 2 times 7x plus 5x, and we know that's got to equal 108, because that's what the perimeter is. So I have 2 times 12x is equal to 108. So 24x is equal to 108. Divide both sides by 24, and you get x is equal to 4.5. So make sure that you answered the question, because here it says determine the length of the room. So now once we know what x is, we could find the length. That's going to be 7 times what we found out for x. So we get 31.5 feet. Alright, example B. Mr. Jones used interlocking building blocks to build a scale model of the Kennedy Space Center in Florida. In the model, 1 inch equals 1.67 feet of an actual space shuttle, and the model is 110.3 inches tall. Alright, so what is the ratio of the model to the space shuttle? So the model, we have 1 inch, and on the shuttle that's actually equal to 1.67 feet. So what we have here, this is called a scale factor. So store that away in your memory banks, because we're going to come back to that scale factor. So we can actually use the scale factor to figure out how tall the space shuttle is in terms of feet. So if I know that 1 inch is equal to 1.67 feet, and I know that the model is 110.3 inches tall, so 110.3 inches, we can figure out how tall the space shuttle is. Notice in my ratios I have inches in the numerator here, so I'm going to have inches in the numerator over here. So then all we have to do is solve this proportion, so I'm going to cross multiply, so I have 1 times x, which is just x, and then I'm going to have 1.67 times 110.3, plug that into the calculator, and we get that x is equal to 184.2 feet. We answer to the nearest tenth. So this is how tall the actual space shuttle is. Alright, so that will conclude this video. We'll continue with the notes at another time, either in class or I'll post another video. Again, make sure you mark down any questions that you may have in these notes and ask them in class, and we'll do some more practicing in class.